listen to this talk. This is not going to be as deep of a dive as the last one. This talk is IPv6 security considerations for when just turn it off isn't good enough. And that quote, just turn it off, is one that I've heard from a lot of people when you mention IPv6 and security. They just shrug and say, yeah, you don't have to call anybody out. You're all here because of that. I'm pretty confident most of you are here just so at the end you can say, but I'll just turn it off anyway. You know? Okay. So I got the idea for this talk from talking with a colleague of mine. You know, I was having this big existential moment. I turned to him and I said, dude, do you think we're ready for IPv6 security? And he looked over and said, doesn't matter, man. We'll just turn it off. And I'm like, we're not in charge. We don't have switches. We can't turn anything off. Our job is just security. So before we go any further, a little bit about me. My name is Jason Lewis. I have a company called Route 6 Security. This is my security job. Just full disclosure, I'm also in the Air Force Reserves, and disclaimer, none of the opinions are theirs, they're all mine, so don't be affiliating with anything. But my background is primarily in business, and I spend a lot of my time thinking about policy, which is probably way different than most of you guys in here. This conference is not policy and business, but it occurred to me when I was having this talk with my colleague before that it is the reason you can't turn stuff off, I believe, that's going to come up, is that as we move forward, here's how I see things moving, is that there's so many IPv6 addresses and so few IPv4 addresses that right now some companies make extra money on the side just selling their unused IPv4 space. It's a revenue producer for some people. And IPv6, on the other hand, they're just giving away. Aaron will just give you chunks of it if you want it. And for that reason, eventually what's going to happen is it's going to be so cheap that startups are going to start using it. This is already happening some places. Startups are going to start using it. They're going to make cool applications that do cool things. And your company, whoever you work for, whatever organization you're in, is going to want to use some of this stuff. And at some point or another, they're going to run into a wall. Right now, you have some places that only do IPv4. You can't do anything with IPv6. It's going to flip at some points, and it's not going to be a killer app. It's not going to be the one thing that you have to have. It's just going to be subtle, and eventually, not being able to use these things, or if you are in an organization that produces some sort of consumer-facing product, you're going to want to be able to capitalize on that market share, right? You're going to want to be able to get to those people who are using those devices or that application that only takes IPv6. And someday, somebody's going to come down and say, you know what? We're going to do this. This is our new business model. And there, look at that. You can't turn it off. Even if you physically could go to the machines and click around and turn everything off, and even if you were able to track down every instance of IPv6 on your network and shut it down, your bosses would fire you. Right, so your position at that point would just be go find a new job or adapt. And so hopefully here today I'm just going to try to get you nudged in the direction towards adapting, if that's where you're at, so we can move on. So the intended audience for this is for security personnel. A lot of the IPv6 security stuff out there is how to configure your network as if you're an administrator. And again, it's great stuff to read. But if you're like me and you do a lot of blue team type of things, or you're looking through network, you're looking for bad guys on your network, you're not really concerned necessarily with how to configure your network, although you will recommend it to people. You are concerned with IPv6 special considerations and how to make that work for you. I also assume that everybody in here is passingly familiar with IPv6, that you at least recognize it as a thing. That if I showed you an address with colons in it, you'd be like, yeah, it's IPv6, move on. It's good. And finally, like I said at the beginning, I assume most of you guys in here are the turn it off folks, or at least people who are familiar with that position and think, hey, maybe I should position myself to take that guy's job whenever he finally butts heads with the business people and loses. So, all right, an overview. Just to give you an idea what we're going to talk about here, I'm going to cover extension headers, logging addresses, attribution, and by attribution I mean figuring out how to associate the network traffic with a host that's producing it, not necessarily a behavior with an APT or something of that nature. We're going to talk about SLAAC, and if you don't know what that is, it's good. We'll get to that as well. Some toolkits that are out there, resources that you should be aware of, and a few takeaways in quotation marks. At the very end of this, you should at least be able to walk away with a couple things that in a meeting you can interject at the right point. Somebody's going to look at you and nod and say, exactly, give that man a raise, or woman. So extension headers. You guys are probably familiar with the issue of fragmentation in IPv4. Right? And it's been fixed by and large in most devices on the network. Fragmentation, being able to bypass firewalls because you're able to hide what is actually inside the packet, is something that is still an issue with IPv6. So the extension headers are very, very long, potentially long chains of information that are right between the actual IPv6 header and then the underlying data. So these long chains could potentially be too big to transmit in one packet, and therefore you might need to fragment them. If that happens, then potentially you could put together, especially if you don't have a stateless firewall instead of a stateful one, then some of these things could slip through and traffic could get into your network that you don't want. So what you need to be aware of is that these extension headers are new to IPv6, but they create issues similar to what you experienced with IPv4. And while the best practices and common sense say don't let that happen, we don't want to have fragmentation, sometimes it's just the way things work. And in particular, there's an issue with turning off fragmentation for network devices that are in between other devices that aren't aware that fragmentation is not allowed. If you break that chain, now you break the whole system, and that makes people unhappy. And once again, people will tell you, you got to switch it back. So, keeping that in mind, it'd be nice if everybody could agree on one standard to implement. But IPv6 implementations of the RFCs vary widely. We get kind of accustomed to IPv4 and how everybody just does what's supposed to happen. They teach it in classes as if there's only one way to do networking, and that is what the RFCs say. Well, in IPv6, there are competing RFCs, there are deprecated RFCs, and if you have any networking device that's been built over the last 10 years, which it's not uncommon to find in many places, you could have a wide range of implementations of best practices and deprecated best practices and alternative best practices implemented there. So if you're not tracking on these things and you're not asking the questions like, what are we doing here, then you might be surprised one day to find out that people are evading your ACLs and potentially DOSing you as well whenever they send these potentially unlimited extension headers through your networking equipment. The hardware implementation can't handle it because it's too big, so it sends it up to your software, and now you're unpacking these extension headers in software and DOSing and getting DOSed. So be aware of extension headers. Another thing, I spend a lot of time digging through logs. I imagine you guys do too. Everybody digs through logs. And in IPv4, there's only one way to write an address, and you guys, that's great. It makes it easy. But in IPv4, so all three of these are one address. Now, the bottom one, I don't think I've ever seen anything record an address that way. Fully written out, all the zeros, all those things. For those who aren't familiar, you can use double colons once in the middle of any of that to get rid of any number of zeros altogether, and then you can get rid of all zeros to the left within the semicolons themselves, so you can make a big address smaller, much like it is at the top up there, although I'm missing semicolons. I apologize for that. Or colons. Anyway, so you're unlikely to see the bottom example, but the top example and the middle example, where you have FE in lowercase and FE capitalized, that seems like a subtle difference. But the best practice that I've read and the one I believe in is the top one where you use lowercase. But there are RFCs that are published, current RFCs out there that use the middle one as their examples. So even the IETF can't figure out exactly what they're doing. It seems small, but whenever you go to use grep, you're going to miss stuff. But if you're writing a script to pull stuff out of these logs, then you're going to miss things. Now, depending upon what you're using to go through your logs, it might take care of this for you, right? Splunk has a plugin that makes it all go away. But if your regex was written by somebody in your shop and it was based on the idea that everything looks like one of these, and then it's not, you could run into issues as well. You might not be logging what you need, and you certainly might be missing information. All right, and now we're going to talk about attribution. As I mentioned before, this is not attribution to an actor. This is attributing network traffic back to a machine. Classically, IPv4 addresses are pretty simple. They'll either be statically assigned or there'll be DHCP leases that are renewed on a regular basis, and it's fairly static. If you look at a week's worth of network traffic, you're going to have a good idea of who is talking to whom, and not a lot of issues there. However, with IPv6, that's more complicated. So one way to give IPv6 addresses is to just let the machines do it themselves. You can do stateless configuration, and they'll make up their own address. And that sounds dangerous, and it can be, but that is why they sometimes check it against other stuff. And they had the clever idea to use the MAC, these EUI64 extensions. What they do is they take those last 64 bits of the address, and then they use the MAC address, and to make it long enough, they shove FFFE in the center of it, and then they flip a bit in the 7th bit from the left, if you're looking at it on paper, and that is their new address. That's great, because that tells you which machine it was. If you know which computer has that MAC address in it, then you should have a good idea. And so that makes attribution fairly easy. And that also, so I want you to take away from this is that if you are lucky enough to just be using these kinds of addresses on your network, that if you see a bunch of FFEs in the middle of your addresses, you can probably reverse that back by reflipping the bit, pulling out the FFFE, and then you'll know the MAC address. And that's how you can figure out who it was, unless you also recorded the MAC address in your logs. However, that's not the best thing to do if you're using those addresses to go out over the internet to conduct business. Some people didn't like the idea that people could be tracking you by this address everywhere you go, and they wanted more privacy, so they created privacy extensions, the privacy addresses. And there's actually a couple ways to do them, but the net result is that they look fairly random. They are randomized. And these addresses provide the user with a little bit of anonymity, which is great unless you're using these addresses to try to figure out what's happening within your network. I mean, privacy addresses are great to go out to the wide world, but from a security perspective, they're annoying, much the way that IPsec can be a problem. So these privacy addresses are difficult, but one of the only ways you're going to be able to figure out these things is by keeping track of the neighbor advertisements. And if that's a new word to you, what you guys need to be aware of is that ARP is dead in IPv6. It's been replaced by neighbor advertisements and the neighbor advertisement, or the neighbor table. So what you need to be doing is recording these neighbor tables, because some of these, depending on the implementation, again, everything varies widely. Ubuntu has a 24-hour standard lifespan for a privacy address. There are other devices that go as low as 4 hours. So what this means is that even if you look at 1 day's worth of traffic, the same machine could be using multiple different addresses to be able to conduct whatever behavior it is. So if you're not keeping track of these addresses, if you're not logging them and retaining those logs long enough to meet whatever look-back responsibility you have, if your organization wants you to be able to look back 30 days, you need to make sure that you're keeping these neighbor advertisements that long. If you're in a situation where, like I sometimes find myself in, where I'm not actually able to affect how much logging is taking place, I am a guest on somebody else's network, and while I'm there, I have to do the best I can. You can also pull these off the wire, and it's a good thing to retain as well, just capturing them, because what these neighbor advertisements are, like an ARP, it's how that client, whenever the information's come back in, is able to say, I am at this address, go ahead and send it to me, and that's going to be your only clue, unless you're able to find it on the host itself. And then finally, I want to talk about the DUIDs, the DHCP user IDs, which are they're interesting because you can have multiple interfaces on your computer these days, right? Like I've got wireless, I've got an Ethernet connection, I've got Bluetooth. All of these are network adapters. Each one of these has a different burn-in address, and the thing about the DHCP, so if you choose to use DHCP-v6 on your network instead of this stateless auto-configuration that I was just discussing, then these DHCP logs will retain this information, and they'll be able to associate this DUID back to a machine. But one thing I want you to be aware of, just a fun little tidbit for your information, you never know when you're going to need it in your back pocket, is that the DUID assigned to a machine is based only off of one of those interfaces. and it may not be the interface that was being used in order to go out. So even though the connection was wireless, it may be referencing the MAC address from the Ethernet card. When this is going to matter to you the most, I don't know. I don't know. But someday you might think back to this talk and be like, got it. That was an obscure piece of trivia he pulled straight from the RFCs. All right, so SLAAC. Strange things with SLAAC. All right, you have router advertisements. So stateless auto configuration, and most of us use the DHCP, where a host comes on and says, hey, I need an address, and the DHCP server goes back to it and is like, hey, here's your address, here's your default gateway, here's your DNS information, you have a good day in internet well. Well, if you're not using a DHCP server, then you don't get that kind of stuff. So to fix this, instead now routers just advertise themselves. They say, hey guys, they use multicast addresses, and they just say, I'm a router. Anybody out there who needs a router, hit me up, like a bulletin board in a coffee shop or something like that. And just like a bulletin board in a coffee shop, you don't know what you're getting. And so some of these, it's very easy to fake a router advertisement. And there are multiple sources out there, multiple scripts that have been written to just generate these router advertisements. And what that'll do is allow you to be a man in the middle. And this man in the middle capability is, of course, one thing that security people don't like. But assuming that the router advertisement is not coming from a malicious source, it could potentially also come from just a misconfiguration. A host gets on the network and says, hey, this is my default gateway, you should try it. The other host picks it up, sets it as their default gateway, and next thing you know, no traffic's leaving your network and you can't figure out why. This is less of a security issue, but more of a problem you might run into. And then this is particularly an issue if you think you turned off IPv6 on your network, so you stopped worrying about it, and now you have the occasional rogue advertisement going around. All right, so Toolkits. Some of you guys are pen testers as well. You're a little less worried about how to track logs as much as you are worried about doing stuff. And also, if you want to be able to figure out what your network's posture is, you may use some of these. The best one, if you type in IPv6 Toolkits, the hacker's choice is going to show up. It's in Kali nowadays. It is robust, and it's never let me down. So there it is. I recommend it. But another one out there is the SI6 Network IPv6 Toolkit, and those guys, they do classes. I think there's one in Paris coming up here pretty soon if you guys have funding. It is also pretty decent. And then finally, SCAPI6. It's not really a toolkit, it's just a tool. Everything that SCAPI can do, it can do too. So you should try it. Craft packets to make sure that your network is actually responding the right way. Making sure these router advertisements are not being picked up when they shouldn't be. Making sure that you don't have other issues I've spoken about. So this is from the SI6 toolkit. I don't know if you can read that back there. It looks a lot better on my computer. But there are all sorts of things that are in this toolkit, and I chose the SI6 toolkit as my example because the hacker's choice actually has far more than I could fit on the screen. It'd be multiple slides worth. But you see here that there are things like IP address analysis and manipulation tool, a tool to perform attacks based on IPv6 error messages, router advertisement forgery. And then one I want you to look at down there is the Scan6, which, near the bottom. It's an IPv6 scanning tool. I wanted to hit on, real quick, bonus, IPv6 scanning. A lot of people think that the obscurity, that having that large address space will give you some sort of security, which we all know is a fallacy, right? Security through obscurity. So I want to let you know that there are people out there developing algorithms to make it easier to scan these large swaths, and those are getting better. But even then, sometimes your admins set your security posture up for failure by doing things like incorporating the IPv4 address it used to be into the IPv6 address. So with any knowledge of the old IPv4 scheme, ta-da, you found it. And even then, scanning the IPv6 space for a 10/8 worth of addresses is just as easy as scanning it in IPv4. Another thing is that you use a service as a suffix, so that would be an NTP server right there. And that's one, people will try that. Your DNS server? Let's just try your address 53. And too often, that's exactly what it is. So if you're able to advise people against this, I recommend it. And the last one is using words in there. And there are a lot of cool words you can create with 0 through F. And finally, takeaway. If you guys are going to take anything away from this, of all the resources I use, all the resources I've read, just read this one. This is a draft RFC written by a guy named Venki, who also was a co-author of IPv6 Security from Cisco Press, he knows a lot. He's been working on this for a long time. This is about 20 pages worth of reading total, and it's like a full primer on IPv6, cuts out a lot of the baloney, and goes deeper into the security issues than I am here. So that's it, one resource. All right, so finally, the takeaways. This is it. So if you get nothing else out of this, you just want to go back and you want to sound a little bit more like you know what's going on IPv6. You want to be ready to take the position of the guy who retires because they almost don't want to bother with it and he just wants to turn it all off. Ask some of these questions. Like, how does our equipment handle extension headers? Oh, good question. We'll make sure we include that whenever we're purchasing equipment. You're a manager now. How are we standardizing our addresses? All right. Are we using capitals or are we using lowercase? Are we using both? Did we download the plugin for Splunk? Yes? Good. Look at me, I'm considering things. Are we maintaining neighbor discovery information long enough to meet our obligations? Will I be able to attribute activity I see on my network to an actor 12 hours from now? Are you relying on me to be able to just go back in there and most of the addresses still be the same? No? Well, we got problems. Sometimes depending on who you work for, you may have legal and regulatory obligations to be able to attribute things. So make sure you're keeping these neighbor discovery logs longer. All right. Does anybody have any questions? I think I have a couple minutes left. All right. Yes?
I have a question, actually. Can you go back to the tools?
Tools. Yep. Did you make one of these?
No, I finished.
Okay. Yep.
Oh, actually, one back. The white page.
White page. Yep. Yes?
Serious question. Have you seen a standard on how people verbally communicate IPv6 addresses?
No. Is there one?
That's hard.
Yeah. The question was, is there a standard way to communicate IPv6 addresses? And I have not seen one. Yes, ma'am?
Are you familiar with CIS benchmarks?
No.
I think Collins agrees with it. Basically, it's just a policy compliance scanning tool you use on images and environments. And they have a specific assessment that just ensures the IPv6 is turned off.
Mm-hmm.
Are you suggesting that maybe not be good enough and we should look further into other?
I do think that. For now, don't get me wrong, I'm not the kind of guy who goes home and sets up an IPv6 home network just for the fun of it. I mean, I have my side network, but my production internet, if my internet went out, my wife would be very upset. My kids too. It's just easier to go with the default IPv4. If it's easier and cheaper, just do it that way. I'm a business background guy. But I do think that one day that there will be a business case for not doing it, and that's what's going to drive it. So yeah, right now in the military too, the STIGs, they also say turn it off. Everybody's saying turn it off, except for the people who aren't. Like Facebook and Netflix and Google and Android. So yes, it's great until it's not. And really all you're doing is avoiding technology. I do think that as security professionals, it's better for our jobs and our future to prepare ourselves for whenever that's not the case anymore. But yeah, whether to turn it off or not, it really depends on your business use case. Yep. All right. Yes, sir.
So basic question with your comment. So Facebook has their set of servers on IPv6 really available right now on the internet?
Yes. As of 2 years ago, their adoption rate was 50%. Internally, and I've seen little exponential graphs that show more. A lot of people are working. ISPs and tech giants are going heavily towards straight IPv6. Now they're going to have to dual stack for a long time, I believe, but definitely if you want a job there, good stuff to know. And also, yeah, that's going to be what's driving a lot of this in the future.
So do we get added from V4 to V6 somewhere along the ISP chain?
I'm not sure how they're implementing it to make it work. I think they're tunneling it is probably the way that it's happening. And yeah, can't speak more on that for them. Sir?
I think just the question around the eventual need to adopt IPv6. Do you think that eventually the need is going to go to people requiring IPv6 to work in order to use IPv6 services? Or do you think just going to put all of the IPv4 stuff behind the NAT?
I believe that startups will lead the way where they can't afford to do IPv4. And then eventually, so everything's going to be tunneled at first. And then somebody's going to be like, why are we tunneling all of this stuff? Every major OS supports IPv6 natively. Every networking device, major networking device, supports IPv6 natively. Why are we spending the extra overhead and resources to tunnel this? And then there it is. All right, guys. Well, thank you. My time is up. I appreciate you guys hanging out for the talk.